All right, cool. So welcome guys to the last basic SolidWorks workshop. So I'll be going over the drawing views and the CSWA practice exam. Okay. Okay, so first thing I'm gonna do is I'm gonna open up a new drawing. And the first thing you'll see is what part you want to put onto the drawing itself. So for example, I'm just gonna put this part, just a random part, doesn't matter. And you'll see that there's 3 different views. So we have isometric. So these view types aren't that important, but I'll just quickly go over it. So isometric, if you can see, the 3 axes are equally foreshortened. So pretty much they all have the same angles. We have dimetric. 2 of the axes is equally foreshortened. So I mean, it just means that 2 of the axes are pretty much equal. And we have trimetric, which is basically where the angles are all different. It's a small difference. Yeah, you guys don't really have to worry about this, but I could just quickly show the different views. So this is where you see the isometric view, and then we have dimetric view, and then trimetric. Yeah. Okay. So here's some more drawing views. So I'll basically be going over each button on the top here. So the first button we have is standard 3 view. So basically, if you click on a model, it'll give you the top, the front, and the right sides. This is like the standard views you'd get to put on a drawing. Yeah, that's pretty much that button. The model view, if you want to pretty much bring up a new part onto an existing drawing, you would do the model view. And what this allows you to do is you can pretty much click a new part and you can select which part you want to put, which view, I guess. Yeah. And then we have projected view. So you'll pretty much, if you want to see like different angles, different sides of an existing drawing, you would pick projected view. So for example, I'm going to click on Alan. What are these? Are you talking about these drawings here? These are just different views of an existing model. Yeah, so if you can see on the left side, this says top view. And if you click on this one, it'll show you the front view. And then this one should be the bottom. Yeah. So I'll zoom in a little bit so it's kind of easier for you guys to see. So if I drag this part, you can see like there's a dashed line in the middle. And what that's telling you is like, that's pretty much like the top or bottom view. So for example, if I go to projected view, depending on which side you pull that out to, it'll show you like different angles of that model. Yeah. So there's that. And we have auxiliary view. So if you have like a weird angle that you want to see the view of, this is the button you would click. So you would pretty much select an an edge on the model. So for example, I want to click on this one, and it's gonna give me that type of view. Yeah. Yeah, so the first section here is basically seeing like what the different sides of the model is. Um, and then the second section, it's a bit different. So we have section view and remove section. These two are really similar. So what section view allows you to do is it kind of allows you to see the cross section of an area. So for example, if I click on section view, I can select if I want it to be vertical, horizontal, or diagonal, whichever way. So if I click here, it's going to show me the cross-sectional view of this line. If you guys can see that. So what these diagonal lines are, they're called cross hatches. And this basically, whenever you see this part, it's basically the cross-sectional view. And a good way to know like what section this is, so whenever you make a section view, you're going to see two letters. And then whenever you make a section view, it's going to tell you what section it is. So section BB, for example, this is BB. Yeah. And then we have remove section. It's basically the same thing. The only difference is you can pick your edges and you can actually make diagonal lines. And it only shows cuts and cross hatches. It's a bit confusing, but just know that they're pretty much the same tool. So for example, if I click this edge and this edge, I can make it diagonal if I need to. So let's see, I want to click manual, so I'll click on this end and this end, and then I'll get a cross-sectional view of that line. Yeah, cool. And then we have detail view. So basically what this does is it kind of zooms into a part. So you can actually make any sketch. So for example, if I make a circle at this point, it's gonna give me a view that's like zoomed in. So if you have like a piece that's kind of intricate and you wanna zoom into a specific part, this is like the tool you would wanna use, detail view. Yeah. Okay, and then next we have a broken out section. So this one's pretty simple. Basically what this allows you to do is you can, you can pretty much cut a portion of the model out and see the inside. So for example, if I do this part, for example, spline. Okay, wait, hold on. Let's start here. Okay, and it's gonna tell me how deep I want this cut. So for example, if I do 0.5, it's gonna cut 0.5 inches deep within, and then you're gonna see that cross section. Yeah, so this tool is good to see if there's a specific part on the inside of a piece you want to like get dimensions of. You would use this tool pretty much. Yeah, and you guys can see the crosshatch pattern. So we know that this is like the inside. And then next we have break view. So essentially what this does is that it kind of cuts the inner portion of a model out. So if I use this one, for example, I'm gonna cut right here and right here. So all that did was pretty much cut out the inner part and left me with like the outer edges. So this is good if you have like a really long piece, like if you have like a 2-foot T-slot, for example, and you have like designs at the end. So you essentially use this view so you can just get the detail of like the ends, and you can change the gap size as well if you really need to. Yeah. And then next we have crop view. So what this one does is that if you make a sketch on a part, it's only going to show that what's inside the sketch. So for example, if I make a circle here, and let's see, I want to make it crop view. So whatever was inside that circle is only going to show up. So yeah, if you're using a part that, you know, like you want to, there's only like a specific part you want to work on, you would probably use the crop view. And that's basically all of the views so far. We have alternate position view, and what this does is that if you have like a model that has 2 states or 2 positions, like a lever, like you want to show one that's on the left or one on the right, you would use that view. And yeah, does anyone have any questions so far? Is that pretty simple?
Yeah.
Yeah. All right. Cool. Okay. So the CSWA. So we mainly use front, right, and top drawing. Yeah. For the most part, you just really need to do the standard 3 view. So here, I'll make a new part just so it's easier for you guys to see. Yeah. So when you load up a drawing, you're gonna see like what parts you want to put on. If it's not here, you can just browse for it, but I'm just gonna use this one for example. So usually you want to start off with isometric view here. And then I'm gonna click on standard 3 view. And that's pretty much it. This is like enough for you guys to make your technical drawings, and you guys can print this out and like manufacture a part, for example. Yeah. Okay. So for the CSWA exam, there's a total of 240 points, and you only need 165 points to pass, which is 68.75%. So the way it works is like, if you get anything above this number, this percentage, like you pass. Like you don't really have to get like a perfect score or anything. You just have to pass the points needed, which is 165. And you guys get like 2 hours on this. And I think there's 14 questions. So yeah, I think that's enough time for you guys. If you guys aren't sure, I think going over certain, actually there's a course on LinkedIn Learning on the CSWA practice. So you guys can look at that if you need any review. But yeah, so it mainly covers drafting, which is pretty much what I covered, part creation and modification, which I'll go over later, and then assembly creation. So I actually have a little quiz for you guys. So question 1, to create a drawing view B, which is this, it is necessary to sketch a spline on drawing view A and insert which SolidWorks view type. So you guys can type it in the chat on what you guys think is correct. So we want to get section B, right? And yeah, Alan got it. Yeah, you're right. It is crop. Yeah, all right. Cool. Yeah, this is like pretty easy. It's pretty simple. You just need to know your different views. And then we'll go on to the next question. So question 2, so to create drawing view B, it is necessary to sketch a spline as shown on drawing view A and insert which SolidWorks view type. So which one do you guys think this one is? It's kind of hard to tell, but Giovanni says B. Jovan and Alan says C. Abel says D. Okay. All right. So the correct answer is C. It is broken out section. So if you guys remember broken out section, it kind of creates, it kind of cuts into the model. It's kind of hard to tell, but you have a little cross hatching on this piece right here. And this inner portion is pretty much like a cylinder. Yeah, it's okay. You guys only need 68.75% to pass. Okay, all right, now this is like the majority of the practice exam. You guys can follow through, but I'm not gonna slow down just because I have like 40 minutes. So you guys can look back at the video and like slow down if you need to. Yeah, so I'm just gonna do this one really quick. So let's see. I'm gonna actually zoom in a little bit. You know what, actually? Okay. So these two are the same question, question 3. You're given a model and you're given some information about this part. So first thing you want to do is you want to make sure you have the right units. So right now I'm in IPS and it's asking for, let's see, millimeter gram second. So I'm going to go to the bottom right and make sure that it's millimeter gram second. Oh. Okay, yeah. And let's see, it's asking for 2 decimal places. So you can actually click on this and click on edit document units. And you want to make sure that it's in 2 decimals. So right here, it's right. You can change it if you need to. Okay, go back. Alan, so basically you have this. So before you want to do anything, before you even want to draw, you want to look at your spec sheet, pretty much your constraints. So what it's asking for is millimeters, grams, seconds. And you're going to change it on the bottom right. These are like different different units. Because if you do it in IPS, it's going to be completely wrong. It's on the bottom right. Yeah. And then to make sure that it's 2 decimal places, you're going to click on edit document units. And then you're going to make sure that it's in 2 decimal places. And you can change this if you need to. Okay, that's good. Material is AISI 1020 steel. So I'm going to make sure that this material is AISI 1020 steel, which is right here. Click apply. Okay, that's good. Okay, you're going to see A, B, and C, which is referring to this part. You have A, B, and C. So essentially what they're asking for you to do is make equations. So I actually enabled my equations here. You can enable it by going to hide/show tree items. And then equations should be right here. Usually it's under hide, but I like to have it as show so I can just work on the equations. So I'm gonna manage, right click and go to manage equations. And then I'm gonna create a variable. So I'm gonna call it A. And then I'm gonna assign a value, which is 81. Create B, which is 57. Create C, which is 43. And basically what this allows you to do is if you assign an equation to a length, you can go to your equations and change the number, and then it'll change your value for you pretty much. So you don't have to go back and look for that certain value. Okay, so I have that. And then I'm gonna go ahead and draw this out. Yeah, I'm gonna go kind of quick. I'm not sure I have a lot of time, but so I'm gonna start at the origin. Yeah, so if you're trying to follow through on SolidWorks, this might be a little too fast for you, so just try to pay attention. Okay, so what I'm gonna do is I'm actually gonna make the outline, which is A and B. So let's see, I'm gonna make this A. So if you click on equal, when you're smart dimensioning, you can actually assign a global variable. So in this case, it's asking for A. I'm gonna give it A, click enter. So now that's A. This one, it's asking for B. So I'm gonna click equal B. Oops. Yeah, so if you notice, I actually didn't assign a variable here because it doesn't have like the summation sign. So I'm gonna make sure this is an equation. Oops. So I'm gonna double click on this, click equal A. All right, so now that's a variable. Okay, cool. So what I'm actually gonna do is turn this whole rectangle into a construction geometry. So basically my shape is going to be within this area, and if it exceeds this area, then I know it's wrong because it can't exceed A or B. Okay. So it's really up to the person to kind of see where, to kind of like know where to start. You guys can start anywhere. It's just, it's up to the person. So I'm gonna start, yeah, I'm gonna draw on site. So I'm gonna refer to these lines pretty much. Yeah, so I'm gonna start here on the bottom part. So let's see, it's a line here. And if you guys notice, if you guys see R, you guys know it's a circle because it's asking for a radius. So it's asking for R5 here and R29. So what I'm gonna do is, you can either use a circle or an arc. I like to use circles. So I'm gonna create a circle here. And then I'm gonna create a circle here. So if you guys can see this, here, let me kind of zoom in for you guys. If you guys see the symbol here, that means it's tangent. So you want to make sure that if you see this, you make sure it's tangent. So I'm actually going to add relations. So I'm going to shift click on the circle and this line here. And then I'm going to add relations tangent. So it's going to make it tangent to each other. And then since it's kind of pointing at 2, so it's telling me that the circles are actually tangent as well. So I'm gonna make that tangent. Okay, so now I'm gonna smart dimension everything. So let's see. So from the distance here is 19. Move this. I'm gonna make this 19. It's asking for the radius is 5. So if you make a circle, it's always gonna be in diameters. So you're gonna have to multiply this by 2. So you can, if it's a big number, you could do 5 times 2, and then it'll do that for you if you need to. So for example, this radius is 29. I'm gonna do 29 times 2. Cool. And then kind of connects here. We have a line on the bottom, and then it goes kind of diagonal up to this point. And then it goes up here. Okay, so from this point all the way up to the end, it's asking for 29 here. So I'm gonna make this 29. Okay. Okay, so from the center of the circle up to the bottom, that's 19. So I'm gonna make that 19. And this kind of tripped me up, but the center of your circle has to be coincident to this line here. So I'm gonna add that relation. So I'm gonna click on the center circle, shift, click on this line, and make it coincident. All right, cool. Let me zoom out a little bit so you guys can see more. There we go. Okay. So I made this line, so that's gonna be up to the top, it's gonna be 24. And we see that there's a corner here, up to here. And this angle is gonna be 45 right here. And the distance from here to this point is gonna be 5. So I'm gonna do that. Okay. See how it's all black? You have black lines, that means it's fully constrained. So now that I know it's fully constrained, I can go ahead and trim the extra part off because it's only asking for this section. I'm gonna trim the rest of the circles off. Trim that off, this one, and this one. And then you should get a curvature like this. Okay, so we have another circle here. We know that it's touching this line and the radius is 19. So I'm gonna do 19 times 2. Right. And we know that there's a line here and it doesn't fully connect up to this line, but it's somewhere around here. And we're gonna make it like that. So now we have like the entire outer shape, but we just need to finish smart dimensioning everything. So let's see. Oh, I actually messed up. Hold on. Extend this line a little because it actually goes here and then it angles down. Okay, cool. So the angle here is 10 degrees. So I'm gonna make that 10. Okay. Let's see. Okay, so I know the entire length is A, so I'm actually gonna make this line touch here because that's length A. And let's see, this is 45. So most of the angles here or the corners are 45 degrees. So I'm just gonna make everything 45. Okay. So the distance from this edge to this point is gonna be 14. So I'm gonna do that. that's 14. Let's see. The distance from this point to this point is 7. So I'm going to do that as well. 7. And, oh yeah, we have a circle in the middle. Okay. So let's see. The diameter of this circle is 14. So I'm going to make that 14. And the distance from, let's see, from the center to this point is 14. So that's pretty easy. So I'm going to do 14. And then from this point to the bottom piece is 14, right here on this line. Click on that, and get 14. Cool. And then let's see, the distance from this line to this line is 32. That's what I'm gonna do. Okay, it's almost done. We have a couple more smart dimensions. Let's see. Okay, so it's asking for another tangent line here. So I'm gonna click on this line and this circle. Oh yeah. Thanks, Yohan. Make it tangent. So now that it's tangent, I can go ahead and trim this. Oh, I messed up. I don't know what this line is. There we go. So these two should be tangent. Yeah, okay. Okay, and then from this line to this line, that's 29. There we go. And then I think all we're missing is this part. So let's see. It's asking for 7. So I'm gonna make this 7. Yeah, so I know I'm kind of going quick. Eventually, if you guys practice enough, you guys can like speed through these parts like nothing. Yeah. Okay. So I think we're done. Let's see. And all we have to do now is extrude it by length C. So I'm gonna go to my extrude. And I'm gonna click is equal to C. All right, cool. And then, so once you're done, it's gonna ask you, what's your overall mass of the part? So you have to be within 1%, 1% of your answer. Let's see if I did this right. So I'm gonna go to mass properties, evaluate mass properties so I can see my mass. And let's see if it matches. So I got 339.54 grams. So cool, we have D, which is the exact number. So yeah, did that right. Okay, that's good. Does anyone have any questions? Otherwise, I'll just move on. Yeah, it seems pretty difficult, but you just have to focus on each part, each section, I would say, and then kind of like relate everything. Some people do it differently. Some people would like draw the whole entire shape and then smart dimension everything, but I like to like start on a specific part and then kind of add to it. Okay, question 4, modify the part in SolidWorks. Okay, cool. So this question is pretty easy. All it's asking you for you to do is change your equations. So I'm gonna go ahead and right click on equations. I'm gonna change these values. So it's telling me it wants 84 for A. 59 for B, and then 45 for C. And what that's going to do is, so the part that I related, it's gonna change those parts automatically. So I don't have to like go inside the sketch and like redo everything. All I have to do is just change the values. Okay, so mass property. So what is the overall mass of the part? So it doesn't, this one doesn't give you any multiple choice questions. So you're gonna have to type it in. So you're gonna have to double check if everything's correct. So yeah, this is the correct answer. It should be 1,032.32 grams. This one's pretty easy. So if you related, if you did your smart dimensions correctly, yeah, if you did your smart dimensions correctly, all you have to do is change your equations and it'll change everything as well. Okay, cool. How much time? Okay. I'll go over this one and then I'll skip to the assembly. So let's see, these images, okay. Okay, so first thing I'm gonna do before I do anything, right, I have to check my constraints here. So I'm actually gonna create a new part. So I'm gonna call this question 5. Save it as a copy. Okay. So my unit system is correct. Decimal places is correct. Everything else is pretty much the same. Let me see if my equations are different, my values. Yeah. So it's asking for A is 86. This one's gonna be 58. This one's gonna be 44. Okay, and then we can go back to our drawing. And this is basically, it's asking for cuts at different points. So I'm gonna start off with this section here, this cut. So let's see. I'm gonna click on this surface, normal 2, and then I'm gonna click on sketch. So let's see, where does this start? Okay, so it's basically this entire section. So I'm gonna make sure that this square encompasses this whole section here. And it doesn't tell me the size of the shape, but it does give me this. So it says 52 from this point to the end point here. So I'm gonna do that, make that 52. Okay, so notice how it moved. That means that I didn't make a relation here. So I'm gonna make sure that these 2 lines are touching. I'm gonna make them collinear. Okay, so that's that. And then it's asking for a cut that's 19 millimeters deep. And there we go. We have this first section already. There's another cut on the bottom here, if you guys can see that. This cut here for this section. Okay, so I'm gonna go back normal to this, to the surface, sketch. It starts at this line here. So I'm gonna click on the edge of this line. There. Okay. And then it's asking for me to cut 19 millimeters deep again. So I'm gonna do that as well, 19. All right, cool. We have that. And then it's asking for a cut on the middle portion. So let's see. It's asking for 12. So this thickness is 12 and the cut is 24 millimeters deep. So what I'm gonna do is I'm gonna go to the back and I'm actually gonna create a new plane. So I'm gonna go to reference geometry, click on plane. And notice here I can change the length of this plane. So I'm gonna make that 12 and then I'm gonna offset it. So that's pretty much this portion here. The plane starts here. So there's that. So I'm gonna sketch on this plane. Sketch here. Okay. So this cut is it's a bit trickier. It's asking for a semicircle because we know that if it's asking for your radius, it's a semicircle. So you can tell the difference between a circle and a semicircle by if it's asking for diameter or radius. But it just kind of depends on the user. I mean, you could still use a circle for this part, but I'm gonna use a center point arc. So let's see. So I'm gonna actually create a center line here as a reference. And then I'm gonna start my arc at this point. And it connects from this side to this side. Yeah, so to make sure that it touches, I'm gonna add some relations to this and to this point. Actually it can go up here, that's fine. Okay. So let's see, it's asking for the distance from this point here all the way up to the top. That's 36. So I'm gonna do that, make that here 36. And I feel like I'm missing something. Huh. Oh, I didn't smart dimension. Okay, there we go. So the radius is 41. There we go. Okay, so I'm actually going to make a circle from here to here because it's asking for a cut, and this is like an open sketch. So I know this is the right dimensions. So I'm gonna go ahead and start cutting. So extrude cut. Let's see, it wants it to be 24 millimeters deep. So I'm gonna do that.
Sorry to interrupt, but how did you the center line that you put above the arc of the circle? How did you determine like the distance between that and the part?
Oh, like, okay, here, let me see. Okay, so
So
like you're wondering the distance from
yeah,
this?
how'd you find that from there to the part?
Okay,
Like,
so basically
semi-part.
you're pretty much you're only given the radius and the distance, right? So sometimes so with these two variables that you have, notice how it's black. So it's already fully constrained. You don't have to determine the distance of your center point. So if I delete this radius here, if I didn't smart dimension it, if I move this around, it's gonna, you see how it changes my radius?
Yeah.
So if I set a certain radius to it, it's gonna set the center of the circle, if that makes sense.
Oh, okay. Yeah, I see. I see what you mean.
Yeah, since this point is 36, right? So it has this has to stay here, but only the radius can change. So I guess I want to say is the center of your circle depends on your radius.
Oh, you get it now. Thank you.
Yeah, no problem. Do that. Okay, cool. And then I think we're just missing one little piece left. That's this circle here. So I'm going to make that. This one's pretty easy. So let's see. It's asking for, the diameter is 11. And the distance from this point is 14. And from here to here is 14. And then I'm gonna extrude cut through all. So it's gonna cut through everything. All right, cool. This is pretty much that part. And then it's gonna ask you for the overall mass. So I'm actually gonna tell you guys the correct answer and I'm gonna see if it's right. So it should be 628.18 grams. But you're not gonna know that on the quiz or the exam. But yes, all right, yeah, okay, I did it right. So it's 628.18 grams. Okay, well, so that's that. And then I'm gonna I'm gonna skip ahead to the assembly because we don't have time to finish the other part. This one's pretty easy. So you can actually get this these models on their website. I'll link it on the YouTube video if you guys want to practice this one. So let's see. I'm gonna go to assembly, and then I'm just gonna add in the parts. So I already have these parts. Let's see. Oh god. Chain link. Okay, cool. So I'm gonna, it's asking for 4 of these. So 1, 2, 3, 4. Okay, and then it's asking for, let's see, 2 long pins. Oops. What's going on? Okay, here we go. 2 long pins. And then we have 3 short pins, the blue ones. Short pins. Short pins. There we go. It's asking for 3 of these. Okay. So basically, so when you make an assembly, the first part you put in is always going to be fixed. Right, so this is the first part that I put in. I'm gonna right click and make it float, because if it's fixed, I can't move it. So I'm gonna make it float so I can move it. And I'm gonna start at this long pin here. So I'm gonna make this one fixed. So usually if you have like an assembly, you have multiple parts, you wanna make a part fixed so that nothing else is moving. And it's asking for your coordinate system to actually be on this point. So what I'm actually going to do is I'm going to sketch a circle here just so I can have a point to click on, because when you make when you use reference geometry, you need something to reference it to. So I needed a point. So I'm going to go to coordinate system and click on that point. So we have that. Okay, I'm going to start mating everything. I'm going to mate this here. Oh, okay. Okay, so mate selections, it's like whatever you guys click on. So if I want to make it concentric, usually sometimes it does it for you. You don't have to click on it, but I'll click on it. So that's concentric. It's basically where the center of 2 circles meet each other. And the top portions meet with each other. So I'm gonna make this surface coincident to this surface. So there, we have that first piece. It's already fully defined. And then next, I'm gonna create the rest of these pins. It's pretty much the same process. Make this coincident here. or concentric. So that's that. And then I'm going to connect this piece here to the middle. And then I'm going to make this surface coincident to this piece. Same thing for this one. Oh, God. Okay. Okay, we got one more. Okay, last piece here. Yeah, so if you guys notice, I'm pretty much doing the same thing over and over. And you guys can actually just create one part and copy it. But I'm kind of lazy, so okay. Cool. Do that part. Okay, that's good. And okay, so what this question is asking you is, it's asking for the center of mass. So basically, notice how we have our A, B, and C again. It's just telling us what degree it wants us to put it as. So I'm still on my mate, and I want to set the angle. So I'm going to click on this. So this one's asking for this surface to this surface. So I'm going to click on that. And notice how it flipped it the other way. Don't want it that way, so I'm going to click that. And I'm going to flip it. So another thing to note is that on assemblies, equations don't really work for some reason. So in this case, you're just going to have to type in your actual degrees. Okay, I'm going to do the same thing for this. Let's see, 125. Cool. And then last one, C. Click on degrees. Okay. Oh my God, it's going crazy. Okay. There we go. It's asking for 130. Yeah, so what this does is that it kind of like switches the side. So notice how it's on the bottom now. So SolidWorks doesn't automatically know what you're talking about. So sometimes you need to align it by yourself. And what flip does is just that it flips the orientation. So I think that doesn't look right. I messed up on the first mate. So there's this toolbar here on mates. So you can actually double click it and you're gonna see all the mates that you have already. So I'm just gonna go here and change it. There we go. That looks correct. Okay, I think I'm done. And then I'm gonna go to mass properties and get my center of mass. So right here it says report coordinate values relative to. If it's on default, I think it just refers to the model itself, but you actually want it to refer it to the coordinate system. Okay, I know what I did wrong. It's in inches. I didn't check. So it wants it in millimeters, right? So this is a little bit more lenient, but just try to make sure that you guys check it in the beginning. Okay, go back to mass properties. Okay, cool. So what do we get? Okay, I messed up somewhere, but it was supposed to be A. But I think that's enough time today. If anyone has questions so far, any questions before I kind of hand it off to Aaron?
Was that the last question?
It's one of the last questions. I didn't have time to go through everything, but so for the assembly, it's mainly just mating, like learning how to mate and deciding what angles. So that's pretty much it for the assembly part. So like the other question, the next question is just different values for your A, B, and C. But yeah, that's pretty much it. Okay. I can redo this part if you guys want me to on a separate date, but I think that's it. So want to quickly go over some tips. Practice makes perfect. Always check what units you're working with, because if you start making a part that's in the wrong units, like it's kind of tricky to change it back to the correct units. Think about design intent. So what this basically is that when you design something, you want to make sure you have the right relations to everything. So if you change one part, everything like fits in perfectly. Find shortcuts, because you don't want to spend like 10 minutes doing a part that you can do in like 1 minute, like copy, like, or any patterns, stuff like that. And just keep challenging yourself. If you find this easy, move on to the CSW, not P, but the next one. Yeah, these certifications they don't hurt to put on your resume. So once you pass the CSWA, the basics, move on to the next step, and then you can move on to your CSW key. And yeah, that's pretty much it for this workshop. So I'll be posting this video on YouTube.